In this video, we will explore some more exercises about functions and their graphs, polynomial and rational functions. And this involves multiple choice and true or false question. So for the part 1, number 1, which of the following equations represents y as a function of x? And we can identify whether y is defined as a function of x if the power of y is an odd number and y doesn't have absolute value. So as you can see here, y is inside the absolute value and also in letter B and letter D. And in letter C, the power of y here is 1 and doesn't have absolute value. So it means the answer for number 1 is letter C. For question number 2, for f of x equal to x squared plus 7, find and simplify the difference quotient f of 2 plus h minus f of 2 divided by h, where h is not equal to 0. So to solve this problem, let us try in this space. So let us solve first f of 2 plus h, which is replace 2 plus h for every x in the given function. So we will have 2 plus h squared plus 7, and then expand this square root of 2 plus h into 4 plus 4h plus h squared plus 7. And then simplifying this, we will have h squared plus 4h plus 11. And then next is, let us solve for f of 2. For f of 2, f of 2 is equal to 2 squared plus 7, which is equal to 11. Now we can find the difference quotient. Difference quotient is equal to f of 2 plus h. Let us substitute. So we will have h squared plus 4h plus 11, and then minus f of 2 which is equal to 11, minus 11 divided by h. So this h. And then here, simplifying this, we will have 11 minus 11 is 0. And then we got h squared plus 4h divided by h. And then let us factor out the h plus 4 divided by h, and cancel out this h because h is not equal to 0. So the answer is h plus 4. So for this question number 2, let us find in the choices h plus 4, and that is in letter A. And then for number 3, which function has the graph that is the graph of y equal to square root of x shifted 2 units up and then reflected about the x-axis? So if we will start with y, which is equal to square root of x, and we do the transformation, which is shifted up 2 units, meaning you will add 2 in the y. So y is equal to square root of x, then let's add 2. And then after that, the next transformation is reflected about the x-axis. When you see reflected about the x-axis, so we have to multiply negative in the y. And the y function has two terms, so meaning you will distribute the negative in these two terms. So y will be equal to negative square root of x minus 2. So this should be our answer, which is choice D. Then for number 4, so if this is the given function and f of 2 is equal to negative 7, then find the value of k. So here we will use the evaluation of function of f of negative 2 is equal to 7 by placing 2 in x of the function f. So we will have f of minus 2, f of minus 2 is equal to 2 times negative 2 squared minus k times negative 2 added by 5. And then let us simplify this. Square root of negative 2 is 4 times 2 is 8. And then plus 2k plus 5. And then we will have 2k plus 13, which is equal to f of negative 2. And it's given that it's equal to 7, so we can place this with 7. Now we can find k by moving or combining 7 and 13. So 7 minus 13, that will give us 2k, which is equal to negative 6. Then dividing both sides by 2, we will get k, which is equal to negative 3. So k is negative 3, which is choice letter B. And then for number 5, if for 7 is an absolute maximum point on the graph of the function f, then which of the following is true? So as you can see here, this f of negative h is reflected about the y-axis, and this negative of f of x is reflected about the x-axis. So if I will create a graph whose absolute maximum point is 4, 7, so for example is um 4, 7. So suppose this is 4, 7, that is the function, and um then which of the following is true? So let us try to reflect this about the x-axis. If I will reflect this about the x-axis, so I will have like this. So meaning it will be positive 4, negative 7. So this point is positive 4, and the negative 7 is the absolute minimum. Let us try to check in the choices. For negative 7 is the absolute minimum on the graph of negative of f of x. And we know that when we have negative of f of x, it's a reflection about the x-axis. So the answer is the choice letter D. There's another absolute minimum is letter C. For negative 7 is absolute minimum of f of negative x. When we have f of negative x, the reflection is about the y-axis, so it's not. So the answer is letter D. For the part 2 of the multiple choice, question number 1, which of the following graphs represents y as a function of x? So here, to identify whether the graph is a function, so we can use the vertical line test. When the vertical line test intersects the graph and it intersects in at most one point, so it means it's a function. So let us try. In letter A, if I will do vertical line test, it will intersect at 2 points, so this is not a function. In letter C, if I will intersect a vertical line in a vertical line, it will intersect in infinitely many points. In letter D, if I will intersect vertical line, it will intersect at 2 points. And then letter B, if I will intersect vertical line in any part of this graph, it will intersect at only 1 point. So it means the answer is letter B. For question number 2, if the graph of the function f has horizontal asymptote at y equal to 1 and a vertical asymptote of x equal to negative 2, then horizontal and vertical asymptotes of the function g, which is f of x minus 1 plus 5 are. So here, let's analyze the transformation. When we have x minus 1, it means it is shifted horizontally 1 unit to the right, meaning the effect will be the vertical asymptotes. It means to say we will add 1 here, so the new vertical asymptote will be x equal to a negative 1. And then for this plus 5, the graphing transformation here is shifted 5 units upward, meaning the change is in y. So the change will be in horizontal asymptotes with y equal to 1. So here, what we will do here is this y which is equal to 1, we will add 5. So to have a new horizontal asymptote, which is y equal to 6. So this is the new horizontal asymptote, and this is the new vertical asymptote. And the answer is letter D. And then for number 3, which one of these functions might have the given graph? So here, let us start writing the function. And as we know, in the given rational function, um, the zeros of the denominators, they are the vertical asymptote. So you can see here that this is a vertical asymptote and this one. So here, the zeros are negative 3. So we will have x plus 3. So we will write x plus 3 here. And then another vertical asymptote, the 0 is at 4. So we will have x minus 4. So if we will look at the choices, x plus 3 and x minus 4. This one, not this. Not letter C, not letter D. So we have two options. And then for this numerator, the zeros of the numerator, those are the x-intercepts. And as you can see in the graph, the x-intercept is only 3. So we will have x minus 3 here. And from A and B, the answer is letter B, because in letter A, the numerator is x plus 3, which is not correct. Then for number 4, for f of x equal to x squared minus 2, find the difference quotient. So let us try to shift this question on the other side so we will have more space. F of x equal to x squared minus 2. So let us copy here. F of x is equal to x squared minus 2. So if we will solve for f of 1 plus h, place 1 plus h for every x in the given function. 1 plus h squared minus 2 is 1 plus 2h plus h squared minus 2. Then we will have h squared plus 2h, and then 1 minus 2, we will get minus 1. So this is your f of 1 plus h. And then after that, we can find for f of 1, and the value of f of 1 will be 1 squared minus 2, which is equal to minus 1. Now, therefore, we can find the difference quotient, which is equal to h squared plus 2h, and then minus 1, then minus f of 1 minus minus 1 divided by h. So here we can see that we can cancel this because negative 1 minus minus 1 is 0. And then we will get h squared plus 2h divided by h, and then factoring out h, the other factor is h plus 2, and then we can now cancel the h here. The answer, we will get h plus 2. So what is the answer? Letter A. And then for number 5, is about evaluation of function. So let us start from this. Placing negative 1 in x of the given function. So we will have f of negative 1 is equal to 3 times negative 1 squared minus k times negative 1 plus 4. So if you will evaluate this right side, so this is 3 plus k plus 4 is equal to k plus 7, and this f of negative 1 is given, which is equal to 12. So we will have 12 here. So k is equal to 5, because we will combine 12 and 7. So 12 minus 7 is equal to 5. So k is 5, which is letter D. Then to continue, for question number 6, the graph of this is reflected about the y-axis. When you see reflected about the y-axis, we will multiply negative in the x. So y is equal to 3 times negative x squared plus 4 times negative x minus 5. So which is equal to 3x squared minus 4x minus 5. So let's check this in the choices. 3x squared minus 4x minus 5, and this is the answer is letter A. Then for number 7, the x-intercepts of the graph of y equal to f of x are negative 7 and 2. So these are the x value or the x-intercepts. Then the x-intercepts of this y with negative of f of x plus 4 are So here, let's analyze the transformation. When you see x plus 4, we have to shift 4 units to the left. So when we shift 4 units to the left, so what we're going to do in the x-intercepts is we have to subtract by 4. So if I will subtract by 4 here, negative 7 minus 4, x is negative 11. And then here, minus 4, so x is equal to 2 minus 4 is a negative 2. And then this negative in y, meaning we have to multiply negative in the x. So these two are the x value. So if we will reflect this negative 11 in negative in y, reflect in the x, right? So this negative in y, so we have to reflect across the x-axis. These x-intercepts are in the x-axis, and as we can see, the change in the function is negative in the y. This is x, not y. So it means to say this is the x-intercepts. Even reflecting about the x-axis, it will stay the same. So negative 11 and negative 2, which is letter C. Then for the last question of multiple choice, what is the domain of the function f with this given? So the domain here, even there's a common factor, it doesn't mean that we have to remove this in the function or in the domain. So in this rational function, as we know, the denominator cannot be 0. And the x value that makes this denominator 0 is 1 and 3. So meaning, from the choices, the answer is all real numbers except 1 and 3, which is letter C. If you will try to cancel out this common factor, which is x minus 3, and you will give a new function f as x divided by x minus 1, still you have to put a condition that x cannot be 3, because you cannot cancel 0 over 0 when x is equal to 3 here. So, but not only x equal to 3, but also since this denominator is x minus 1 and 1 is not allowed, so you should include 1. So that's why letter C is the answer. So that's for the multiple choice. For the true or false question, we will write T if the statement is true, and otherwise write F. So for this part 1, it says in question number 1, both function f and g have the same domain. So let's check the domain on the first. The domain here is because of this x, so meaning it's all real numbers except 0. And here in the function g, x minus 1, that's a polynomial, meaning it's all real numbers. And take note, even you simplify this to x times x minus 1 divided by x, and you cancel this, you have to put x is not equal to 0. That's why that's the domain. So they don't have the same domain, so that's why this is false. For question number 2, both points 318 and negative 318 lie on the graph of an odd function. If you will check 318, 318 is here in the first quadrant, and then negative 318 is here on the second quadrant. And when we say add function, meaning the symmetry is origin, but these 2 points, the symmetry is the y-axis, meaning this is also false. For number 3, if the function is increasing on the interval 1, 2, and take note this is x values, both of these are x values, and it is increasing, let's say for example, it's increasing like that, and then it says here that f of x plus 1 is also increasing on the same interval. This statement is true because when we have the function f of x plus 1, it is shifted 1 unit upward. So if I will shift this 1 unit upward, it will be still the same, increasing on the same interval. So it's true. Then for question number 4, the graph of f, which is this, has at most 5 turning points. So let us identify the degree of this function, and it looks like the leading term is this and the degree is 6. So when we have degree 6, when the function is degree 6, then at most 5. When you see at most 5, yeah, this one, at most 5 turning points. So this statement is true. Then for number 5, the graph of the rational function may intersect its horizontal asymptote. Yes, that is true, because there is some rational function that intersects in horizontal asymptote or oblique asymptote. But any rational function never intersect the vertical asymptotes. But for horizontal, yes, it may intersect. So that's the true or false question. That is the end of this video. If you find this video useful, please like and subscribe and turn on the notification bell so you never miss out on the future content.